Hi everyone, today in Integrated Math 2 we're going to go over Chapter 9 Lesson 4. Here are your objectives. Make sure you write them down in your notes. Alright, so our first theorem, triangle proportionality theorem. If a line is parallel to one side of the triangle and intersects at the other two sides, then it divides the sides into segments of proportional lengths. So in our case, for this picture, we're saying if BE is parallel to CD, then we will know that AB divided by BC is equal to AE divided by ED. Alright, so let's look at this. Triangle proportionality theorem. So remember what the theorem says is if these two lines are parallel, then we can set up the proportions to be equal. So in our case, A divided by B would equal C divided by D. So if I'm changing this in any way, notice how the proportions are still the same, no matter what I do. And that also includes if I change the triangle to look a little different. Notice it's still 2.53 on both. If I move it all the way up here, 0.25 on both. They are proportional. And that's what this theorem is telling us. Next we have another theorem, converse of triangle proportionality theorem. If a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then the line is parallel to the third side of the triangle. This should sound familiar because it is. When you see converse, that just means the reverse of, in our case, of this triangle proportionality theorem. Now we're just saying this theorem kind of backwards. So now we're saying that AE divided by ED is equal to CD divided by DB. If that is true, if they are proportional, because they are equal, then I know that AC is parallel to ED, which is just the flip version of the other one, the swapped. So just keep that in mind. It should sound familiar because it is very familiar. The if and thens just swapped places. A midsegment of a triangle is a segment with endpoints that are the midpoint of the two sides of the triangle. Every triangle has three midsegments. The midsegments of triangle ABC are RP, PQ, and QR. Now let's go over the theorem for triangle midsegment theorem. A midsegment of a triangle is parallel to one side of the triangle, and its length is 1/2 of the length of that side. So in our case, if J and K are midpoints between F and H and G, then that would mean that JK is parallel with FG. And then we can say that JK is equal to 1/2 of FG. Alright, so let's look at this for the midsegment. So notice here what they're saying is this is congruent to this, and this is congruent to this. We're going to keep on going. So here we have the midsegment. Remember what it's saying is that this is 1/2 of this, which does make sense because we have two of these, and there's one here. That's 1/2. So that's where that's coming from. Then we have a corollary, proportional parts of parallel lines. If three or more parallel lines intersect two transversals, then they cut off the transversal's proportionality. So Right here, we have 3 parallel lines that's indicated with these arrows. So here we're saying if AE is parallel to BF, which is also parallel to CG, then we know that AB divided by BC is proportional to EF divided by FG. And here's our second corollary. Congruent parts of parallel lines. If 3 or more parallel lines cuts off congruent segments on one transversal, then they cut off congruent segments on every transversal. So here we have AE, which is parallel to BF, which is also parallel to CG. And with that, we also know that AB, which is congruent to BC. If we have all this, then we can say that EF is congruent to FG. Alright, so here we have 1, 2, 3, 4, 5 parallel lines. And if we know this is congruent, which then means that this side, each of the lengths between the parallel lines will also be congruent. So as these change, notice all the values on this side, in our case the left, are congruent, just as the ones on the right are also congruent. And that doesn't matter how the angle changes, it remains the same. Let's see if that's gonna. So even if we make it really weird, it's still not going to change it. It's going to remain the same. And that's perfect for exactly what we're trying to prove. And there we go.